This presentation is the second part to our anatomical terminology section. We're going to talk about terms related to motion and position, and then open chain versus closed chain motions. To start, we're going to do a review of the planes of motion. And so we have the frontal plane, the sagittal plane, and the transverse plane. We're going to break down the motions of the joints throughout this presentation into their respective plane which they belong. There's different types of joint motions. We're going to be very simplistic in the joint motions and focus mainly on the larger joints of the body. But there's single plane motions, and those are kind of like a door hinge. So they just kind of swing and only operate on one plane. So they could easily be said like this is flexion of the knee, and that's happening in the sagittal plane. So it's just a single plane motion. So when you're dealing with or building an orthosis for a single plane joint like the knee, it's relatively simple to build the device. You don't have to really worry about one range of motion. So some joints don't just work in a single plane, they can also have motion in multiple planes at once. So the hip is a great example of this. The hip can be brought up like this and be brought back down to extend it. So we can flex and extend the hip in the sagittal plane. And then in the frontal plane, we can bring our feet in or we can bring our feet out. And that would be a frontal plane motion that's happening at the same hip joint. And then finally, down here, we can rotate our hip joint. So we can take and turn our foot internally and externally, whichever way we like. So the hip can actually function in all three planes compared to like a knee joint or an elbow joint, which only functions in one plane. The next terms we need to know are flexion and extension. Flexion is increasing the joint angle, and extension is decreasing the joint angle. In this picture down here, we can look at the knee, and we can see when the knee is fully extended, we consider that to be 0. So it would be a measurement of 0 on full extension. On the other hand, we can flex the knee, and as we flex the knee, the number or joint angle increases. So now this patient's at around 90 degrees. So flexion means an increase in joint angle. Extension is a decrease in joint angle. When you're thinking about flexion and extension, sometimes it gets confusing because you can look at a person's body and the hip may flex one way and the knee may flex the other way. And how do you figure out, which is flexion and which is extension? If you're in flexion, you're kind of assuming the fetal position like this person is here. So you can see that his knees are flexed and his hip is flexed, arms flexed. So what this does, if you just think of someone in the fetal position, you can then kind of figure out which way is flexion and which way is extension, because when you're in the fetal position, you're kind of in the smallest ball that you can possibly make yourself fit, and when you're extended, you're in the largest that you can make yourself. So flexion and extension. Now we're going to go into adduction and abduction. The definition of this is the distal end is towards the midline for AD or adduction, and the distal end is away from the midline for AB or abduction. One of the things with these two terms is they're very, very easily confused when you're talking with someone. Even when you're writing it down, you can write the wrong one down because there's only one letter difference. And so it's often good, instead of saying adduction or abduction, which kind of sound the same, to say adduction or abduction. It just makes for better communication and less problems. So abduction or adduction. So add is you're bringing the legs in towards the midline. So this picture here would be a picture of adduction. And abduction or abduction is when your feet are going away from the midline. So abduction over here and adduction over here. The way I remember this is simply abduction, abduction. When you abduct somebody, you throw them in the trunk of a car and you drive away with them. So same thing with this. We're going to move your feet and drive away from the midline. So dropping that mid-sagittal line down, we're going to drive away from the midline for abduction. The next one we're going to do is inversion and eversion. This is really, really similar to abduction and adduction. The difference is that this is just related to the foot. So we typically talk about inversion, meaning the sole of the foot is rotated towards the midline. So you can see how the sole of this person's foot is rotated towards the midline. And eversion is the sole of the foot is rotated away from the midline. So this is just happening down here at this what's called the subtalar joint. We have our ankle joint up here, and then the subtalar joint down here is providing this motion. So eversion is away from the midline, inversion is towards the midline. So rotating the sole of the foot either towards the midline or away from the midline. Internal and external rotation, these are typically viewed in the transverse plane looking down from the top. So if we look at this person's feet, we can see that they're externally rotated. So these feet are externally rotated. The toes are going out away from the midline of the body. And here we have internal rotation. So the toes are pointing in towards the midline of the body. So internal and external rotation. You'll also sometimes hear of this called as medial and lateral rotation. So medial would be internal and lateral would be external rotation. But I think external rotation and internal rotation are the more common terms, and that's the ones you'll be tested over in this. Those are the different types of motions. Now we're going to break down the motions by plane. So we're going to be talking about abduction, we're going to be talking about flexion and extension, but we're going to break it down to the joints of the body and which plane it happens in. So we'll do all the frontal first, and then probably the sagittal, and then the transverse. So the frontal plane motions, the first one's going to be AB and AD ductions of the shoulders. So you can see how you can bring your shoulders out into abduction or abduction, or you can bring them down by your sides into adduction. So that's shoulder, abduction, and adduction in the frontal plane. Then we have hip, AB, and AD duction. We just went over this once already, but it doesn't hurt to go over it twice. So abduction is away, and adduction of the hips is towards. We're going to have inversion and eversion of the heels. So the foot can invert towards the midline or evert away from the midline in the frontal plane. Now we're going to move on to our sagittal plane motions. So with the sagittal plane, we can flex the hip. So this would be hip flexion, and then we can extend the hip. This is hip extension. Then at the knee, we can do knee flexion, and we can do knee extension when she's standing straight up. You'll notice that the hip, when we did flexion, just to go back real quick, flexed forward. So she brought her leg forward when she flexed her hip. But when she flexed her knee, she brought her knee backwards or posteriorly when she flexed her knee. So all motions don't travel the same way. Flexion and extension doesn't mean the limb's always going to move forward or always going to move back. It's referenced directly to the joint that you're talking about. So this is knee flexion, knee extension. Then we have sagittal plane motions. This one's a little bit different. The ankle gets its own terminology. And basically you have dorsiflexion, and dorsiflexion is when you raise the toes up, and then plantar flexion is when you push down like you're pushing on a gas pedal in a car. Dorsiflexion, the top of the foot is called the dorsum, so that's where the dorsi comes from, the dorsiflexion. And then over here, plantar flexion. Plantar is just the old word for earth or ground or dirt, and so when you're plantar flexing, you're pushing down into the dirt. Now we have shoulder flexion and shoulder extension. So this would be flexion, where you flex the shoulder up, and then extension is when you bring the shoulder down, like that. Those are kind of the basic joint motions. There are more joint motions than that, and we will get into those more in depth when we go into each device that we're going to be making. So when we go into lower limb orthotics, or let's say an AFO we're going to be making, there'll be a section on all the motions that happen within that area which the AFO controls. But for just starting, that's a good start for us. And finally, we're going to talk about open chain versus closed chain. And this is a concept that is kind of important for us. It has to do with gait. It has to do with when your foot is planted on the ground and when it's swinging through the air. But you'll be working in both ways. Sometimes you'll be looking at a cast and you'll be looking at an open chain. And then other times you'll look at a cast where you have it planted on the table and you're moving the shin back and forth, and that will be a closed chain adjustment. It's the exact same motion, it's just a difference of how you look at it. It's kind of a perspective thing. So open chain is when the motion happens at the foot, let's say the ankle for example, and it's not planted on the ground. So the foot moves up and down like this. Closed chain is when the foot is planted on the ground, but then the foot's planted on the ground, but then the body moves on top of it. So the foot doesn't move, that the body moves. So the proximal segment has motion and the distal segment does not. So that's open chain versus closed chain. Please stay tuned for our video review of the content covered in this section.